Okay, someone remind me what it means for something to be a function. Someone remind me what a function is. Anyone remember what a function is? Or maybe what makes something not a function?
Oh.
You look like you got something, Ryan.
If like multiple inputs don't have the same output.
Yeah, so a function is each input has one output. So this is, I'm going to say, a rule where each input or x is mapped or matched to exactly one output, which is our y. Or the official definition says a rule where each element x in a set A is assigned or mapped to exactly one element f of x in a set B. So basically just there's exactly one y for every x. So if we have multiple x's for the same, or multiple y's for the same x, it is no longer a function. The way that when I'm doing this with my freshmen is just kind of, you want to know if you have an input, you want to know exactly what's going to happen. If there's multiple outputs, then it's kind of hard to know exactly which output you're referring to. So we know what a function is. We also we're going to talk about domain and range. Someone remind me what the domain is. What was that?
The left and right values for where it is.
Say that again. Sorry.
Yeah, where a function is graphed and then like the left of it and the right of it.
Yeah, so the left and the right, or we can say it's all of your x values or all of your inputs.
That's a really good one.
So I'm going to say the set of all inputs, which is x. And then what do we call the outputs or the y values? The range. So this is all stuff we've been doing since secondary 1. So range is the set of all outputs, which is your y, or a lot of times we'll see it written as f of x. So we're going to just talk real quick about function notation. And then we are going to be looking at some slightly new things. So, any questions on those definitions? Like I said, this is all stuff that you first learn in secondary 1. I taught, I think, some of you this in secondary 1. I think I got a few of you that I had when you were in 9th grade. Some of you I had later, but I taught some of you this for the first time back in the good old days of 9th grade. Okay, so let's look at what function notation. We're just going to review over what this is. Once again, this should be review, released right now. So I'm going to say f of x equals, and I'm actually going to do a piecewise function. Piecewise function, so this is like, we're going to secondary 2 right now. So we have x squared if x is less than 0, and it's x plus 1 if x is greater than or equal to 0. So we're just going to look at just a couple of these using our function notation. So if I said something like, find f of -4. I want to know what is f of -4. Am I going to use the top part of this function or the bottom part? We're going to use the top. How do we know we're using the top? X is less than 0. And so this would be -4 squared, which is 16. Okay. What if I asked you to find f of 0? Which of these would I use if I said find f of 0? We use the bottom one. Why are we using the bottom one? Because we have that equal to. And so this would be 0 plus 1, which is 1. And then if I just said any number bigger than 0, something like f of, 20. Once again, which part am I going to use? I'm going to use the bottom one as well because 20 is bigger than 0. So 20 plus 1 is 21. Okay. Any questions on using function notation? This part should be just plugging numbers in for x. So the next thing we're going to do is something we haven't necessarily talked about before, but it's not anything that's super crazy difficult. We have what's called net change. So what net change is this is saying, let's take something like f of b minus f of a. So we're going to subtract your outputs where b is the bigger number. So b is greater than or equal to a. So we're going to look at 2 examples of doing net change. So for this example, I want to find the net change. We're going to do 2 of these, but I'm going to do it with f of x equals x squared. So I'm going to give 2. I'm going to do this twice. So the first one I'm going to say, let's do this from one to 3. So all this is telling me to do is take f of 3 and subtract f of 1. So we just plug in your 3, plug in your 1, subtract them. So it'll be 3 squared minus 1 squared. That's 9 minus 1, which is just 8. Questions on that one? Okay. Or if I said do this something like from -2 to 2, all I'm saying to do is take f of 2, subtract f of -2. So plug those in, 2 squared minus -2 squared. What do we know about 2 squared and -2 squared? Those are both 4. So what is the net change here going to be? It's going to be a 0. Okay, questions on net change? So we're just looking to see how do my outputs change between 2 different inputs. It is possible for net change to be negative because if my graph was decreasing. So if I had said like from -2 to 1, sorry, if it was increasing. Sorry, no, if it was decreasing. It is possible for your net change to be a negative number. If it was -2 to -1, when we subtract your outputs, it would be small minus big, which would be negative. Okay, any questions on that? Okay. Next thing. So the next thing we're going to look at is, so we're going to do our function notation, but it's going to be, we're going to do some stuff with it. Talk about what's called the difference quotient. So for this example, I'm going to give you a function. We're just look at f of x equals 2x squared plus 3x minus 1. So I'm just going to plug some different things into this function, except for we're not going to use numbers. I'm going to plug some different variables in. So the first one I'm going to look at is, I want to find what is f of a equal to. What am I going to do with that a? I'm just going to replace the x's. So this would be 2a squared plus 3a minus 1. And that's all we're going to do. There's nothing else we can do to simplify it. That is my answer. Questions on that? I could also say something like, let's find f of negative a. So I'm going to replace my a's with a negative a. So 2 times negative a squared plus 3 times negative a minus 1. Am I going to multiply the 2 and the negative? Is that what I start with by doing, is going 2 times, this would be a -2? Is that how we start? So make sure order of operations. Don't be like my 9th graders. We want to square this first and then multiply by 2. So this is going to be 2. It's going to be a positive a squared. This a doesn't have an exponent of 1, so it's going to stay negative, so that'll be minus 3a and then minus 1. Okay. So these two, nothing too crazy. For the next one, though, we're going to go a little crazy. We're going to say f of a plus h. So I'm going to replace each of my x's with a plus h. And then I do want to simplify this. We want to distribute everything out, combine all our like terms. So remember, if I have a plus h squared, this is not a squared plus h squared. Where this is 2, it's a plus h times a plus h. I'm going to go ahead and maybe distribute that -3 right now just because we can. You can wait to distribute it or just distribute it. We're going to distribute all of this out. When we distribute it, we end up with, it's going to be an a squared. And then we'll have a plus h and a plus h. So we're going to have two of those. So 2h and then h squared. And then still just your minus 3a minus 3h minus 1. Except for that's a plus 3. I just realized I wrote that down wrong. That should have been a plus 3. So all those are pluses. It's because I went and looked back at this when I plugged it in and not this when I plugged it in. So pay attention to your negatives. They can make or break the whole thing. So pay attention to your negatives. Any questions getting here? Okay. And then I'll just go ahead and distribute the 2. So 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Do I have any like terms? Is there anything we can combine at all? No. So it doesn't look like there's anything to combine. So this is how I'm going to just leave my answer is like this. So this is the answer for this part. Okay. So we're going to do one more thing with this function. We're going to find what is called the difference quotient. So what we're going to do is we're going to do f of a plus h minus f of a all divided by h. I don't know, is there anyone in this class that's done any calculus at all? I feel like every year I have at least someone who maybe started calculus and dropped it, or anyways, this is something that ends up coming up in calculus. So if you end up taking calculus, this is going to come up a lot. This is what's called the difference quotient. Essentially what this is we're finding the slope between two really super close numbers. So we're saying we're looking between two numbers that are really, we're trying to make them really close to each other. We're trying to make this h as small as possible. And that ends up playing a big role in calculus. A lot of calculus is just, we're looking at rates of change or slopes at very small sections, small pieces of a graph. So we've already found f of a plus h. That's what all of this was. So f of a plus h is our 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. And then we already know f of a. There's a reason why we did each of those separately. F of a was our 2a squared plus 3a minus 1. And then all of this over h. And then we're going to go ahead and simplify. So I'm going to distribute my negative, combine like terms, and then we're going to see what happens when I do that. And actually, maybe not going to necessarily write out distributing the negative. You can write it out, or actually, I am going to write out distributing the negative. So if we distribute the negative, I'm still going to have the 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. And then it's going to be minus 2a squared minus 3a plus 1. All divided by h. And then we'll go ahead and just combine all of our like terms and see what happens at that point. Any questions here so far? So 2a squared, does 2a squared have a like term? What happens when we combine those like terms? Cancels out. Does 4ah have a like term? No. Does 2h squared have a like term? No. Does 3a have a like term? Yes. What happens when we combine those? That's gone. Does 3h have a like term? No. Does -1 have a like term? Yes. What happens when we combine like terms? That's gone. So everything that does not have an h on it, when we combine like terms, is gone. So this, when we subtract this, it subtracts off everything with an a. So I'm left with 4ah plus 2h squared plus 3h, all divided by h. What do you guys notice about every term in the numerator? They all have an h. I'm going to factor out an h so we can divide that off. So factor out that h. And now that h divides away, which leaves me with my answer is 4a plus 2h plus 3. And then it ends up that if we were to replace that, basically get rid of this h, so we try and make h as small as possible. So essentially say, let's make that really, really close to 0. This 4a plus 3 is what's called the derivative of this function, which if you take calculus, derivatives are a big part of the first half of calculus, and then there's what's called integrals, which are the second half of calculus, which we're not going to get into any of that in this class, but just kind of thinking about how all of this relates to what's coming next. Okay. So the last thing we're going to look at today is finding the domain of various functions. So we're going to start simple and then we'll get a bit more complex. So we're going to find the domain. We're going to do 6 functions. Like I said, the first one's going to be relatively simple, or we can just look at it and immediately know the answer. So the first one is f of x equals 2x plus 7. What is the domain of a line? If I have a straight line, if it's a linear function, what's my domain? So the domain is just going to be negative infinity to infinity, because this is just it's a linear function. So polynomials all have a domain of negative infinity to infinity. It's once we start looking at more complicated functions where we start having denominators, we start throwing in square roots, we start looking at logarithms, that's where our domain ends up getting a little bit more complicated. So the next one, we're going to go g of x equals 1 over x squared minus x. So when I have a fraction, I'm going to look at my numerator and denominator and see what kind of restrictions we have on our x value. Is there anything in the numerator that's going to cause problems here? No, it's just a 1. So that's always a 1, no problems. But what about the bottom of the fraction? What do we know about the bottom of the fraction? What can it not be equal to? So what number can you not divide by? You can't divide by 0. So if we think back, like 1010, when we found our, what do we call them, restrictions, or do your excluded values, or whatever we want to call them. That's basically what I'm going to look at here. So I'm going to factor this. This is x times x minus 1. What numbers do we know x cannot be equal to? What two numbers can x, what are my two restrictions on this function? 0 and 1. So we have x can't be 0, and x also can't be 1. So I know x is not 0, x is not equal to 1. See if I can get this in a good spot. And the reason x is not 1 is because x minus 1 is not 0, which means x is not 1. So when I'm writing the domain, I do want to write it in interval notation. I think it's helpful when doing these to think about the number line. So if I look at my number line, 0 and 1 are the only two places that cause any kind of problems. I know I can't include 0. I can't include 1. But are there any other numbers that are giving me problems? So my domain is all of this except for 0 and 1. So I would say it's negative infinity until we get to 0. Parentheses because we're not including it. This is where, and do you guys remember what I put next to show that we're combining two pieces? Your u. So this is our union, or our u, 0 and 1. U, and then 1 to infinity. So where that u is our union, it's just basically saying we've got multiple distinct sections that are part of my answer that I want to combine or unite them together in a single answer. Questions on this rational function? Which we went over some of this in 1010. We did it in Sec 3. We are going to also throw in some square roots. So for this next one, I'm going to say maybe h of x is the square root of x plus 1. Assuming we want to live in the real number system and not start dealing with complex numbers. Complex numbers will come later in the class. What do we know about the square root? What kind of numbers can we have under a square root in order to keep this all real? Positive. Is there anything else besides positive? There's one other number we can include that's not positive. 0. So I have x plus 1 has to be greater than or equal to 0. And then if I solve that, we get x is greater than or equal to negative 1. Or if I do that in interval notation, it starts at negative 1 and then just goes to the right for forever, to infinity. Okay. Any questions on that? Okay. For the next one, we're going to combine two things we've already seen. I mean, we call this k of x. So I have 2x. I'm going to take my 2x plus 7 that we had at the beginning. That was our a. And then I'm going to divide that by the square root of x plus 1. So when we have a fraction, we're going to look at and see what do we have from the top of the fraction, what do we have from the bottom of the fraction, and then we combine them and take the most restricted amounts. So if I just looked at the numerator, what would the it was just the numerator, what was the domain of the numerator of this fraction? Negative infinity to infinity. If I look at the denominator, if it was just the square root of x plus 1, that's what we just did. We'd say x plus 1 is greater than or equal to 0. However, can we include 0 when we're doing this problem? No. Can the bottom of the fraction equal 0? No. So when I'm looking at this, we know square root of x plus 1 cannot be 0, which means x plus 1 is just greater than 0, which means x is greater than negative 1, which means it's negative 1 to infinity without including the negative 1. Okay. Any questions on those ones? Okay. So we have two more that we're going to look at. Okay. So next one I'm going to be called j of x. I could call these f of x, but we're going to just mix it up because we can. I'm going to do something like the square root of 9 minus x squared. Okay. So we need to find, since this is a square root, we have to have 9 minus x squared is greater than or equal to 0. And I don't think we've really done much with nonlinear inequalities. Previous versions of 1010 had nonlinear inequalities, and then last year they got rid of it. So this is going to be, we'll go over this. So what we're going to do, if there is an inequality that we want to solve and it's not linear over here, I'm going to solve this as though it's an equation. So we want to solve 9 minus x squared equals 0. So that would give me 9 equals x squared. If 9 is equal to x squared, what two numbers can x be equal to? 3 and negative 3. So I have x equals plus or minus 3. So now we need to figure out, well, where are all of the rest of the numbers with my answer going to be located? So I'm going to make myself a number line. So I like using number lines when we're not looking at linear, like where it's a little bit more complicated. So I know I've got negative 3 and 3. I'm okay to include negative 3 and 3 because if I plug in a 3 and a negative 3, it's just going to make a 0 there, which is fine. But I don't know whether I can include the rest of these sections. So what I'm going to do is I'm going to choose a number in each of these, and I'm going to plug it into my function. I'm going to plug it into my inequality. I'm going to make sure that this inequality is true. So what is a number that's less than negative 3? Negative 4. So negative 4 is simple. So I'm going to say, let's go negative, plug in a negative 4. Negative 4 is right here. 9 minus negative 4 squared. I want to know, is that greater than or equal to 0? We'll simplify that. That's 9 minus 16 or negative 5. I'm saying negative 5 is greater than or equal to 0. Not negative 5. Negative 7. Is negative 7 greater than or equal to 0? No. So I'm going to say this is false, which means we're not going to include anything in this part of the graph. Let's choose a number between -3 and 3. 0. So 0 is what I would choose. If I have an option of any number to choose, 0 is my favorite number to choose for this type of thing because you plug in a 0 and it's just 0. So if I do this section right here, 9 minus 0 squared, we're saying is that greater than or equal to 0? Or in other words, is 9 greater than or equal to 0? Is that true? So that is true. So I'm going to end up including this section right here. And then I'm going to choose the number bigger than 3. Double check that section. What? 10. So just any number bigger than 3. It could be a 4. You could even go crazy and say 3.01 if you wanted to. But we're going to go 9 minus 10 squared. We want to know, is that greater than or equal to 0? Or in other words, is 9 minus 100, which is negative 91, greater than or equal to 0? Is that true?
No.
Oh, that is very false. If you think that that's true, then I can probably find some, I don't know, middle schoolers. They can give you, you can find some, they can help you know that negative 91 is not bigger than 0. So the only section we have for this is this -3 to 3. So my domain is -3 to 3.
You use the brackets when it stops there, right?
So the bracket means you don't go past it, but you can include the number. Parentheses means you get really, really, really close, but you don't actually reach there. Like if there was parentheses here, you would say, well, let's go to 2.99999999999. That'd be like my open circle. But once you get to 3, you no longer include it. Okay. So I just have one more I want to look at. We're going to look at maybe call it Q of x is the square root of x divided by x squared plus 5x minus 14. So I'm going to look at the top and bottom separately. So from the top, what do we know about x? So from the top, x can't be negative, so x is greater than or equal to 0. If I look at the bottom, since it's on the bottom of the fraction, I know x squared plus 5x minus 14 cannot be equal to 0. And then I'm going to go ahead and factor it, find what those restricted values, those restrictions would be. What do I have that multiplies to negative 14 that also adds to 5? 7 and negative 2. So x plus 7, x minus 2. So what two numbers can x not be equal to? So x can't be 2 and x can't be negative 7. So these are just the two numbers that make these equal to 0, which means we know x can't be those. So we've got several things going on. We know x is bigger than 0. X can't be those two numbers. Once again, I think it's helpful to put all of this onto a number line to help visualize what is happening. So the three numbers we had negative 7, we had a 0, we had a 2. I know x can't be negative 7. But I also know x has to be bigger than or x can be 7, negative 7 or 2, but x has to be greater than or equal to 0. Did this negative 7 even play, is that going to play any role in our domain? No, so this right here, we're not going to do anything with there. So this starts at 0. It goes all the way to 2. It actually goes to 1.9999999999999. But once we get enough 9s that it bumps it up to a 2, we don't include that anymore. And then once we get past 2, so to do your 2.000000000, lots of zeros, 1, start over again, and then go to infinity. Which gives me this as my domain. Okay. Any questions on any of that?